Well, already we talked about the Markov decision process and the cumulative discounted reward. And now, what is the problem? Why we define this MDP?
Okay. What we have done here is to define the all the tools we need in
Yeah.
transforming. But at the end, the problem of this is to try to maximize something because we want something from that, and that is the total discontent reward. How do we do that? Is just finding a policy
Yeah.
that based on a state, uh, he's going to tell us if the decision is good or bad based on the state.
Uh-huh.
So
And they maximize the of the total reward that he receives in the future and only one step, you know? That is
yes,
something important because maybe our policy only can be blind and only make the best action in one state that is not the same that they make all the sequential actions that that give us the better policy. So how do we evaluate the performance of this policy?
uh, one option is to choose a policy pi that would maximize that amount.
This
This,
cumulative function, no?
yes. Uh,
Okay. And how we gonna do that? We are going to do that with value functions, you know. Well, this in this part, almost all the reinforcement learning algorithms are based on this estimation of the value function. That value function tell us that how good is for the agent
to make
to
an
be
action.
in a state or to be in a state action pair, and how we're going to measure that with the future rewards. So the first value function that we are going to talk is the state value function for policy P. So all the value functions are we're going to define in a specific policy, all the possibles. And in this part, in this tell us the expected return when starting in S and following with the policy P, starting in the S state.
Uh, it's important to mention that we don't care about the action. It's only the state we are.
Yeah. So this part, this is a mathematical expectation, but only tell us the current state and the expectation of the future rewards. Also, we have the action value function for policy. So this is
What is the
something,
difference?
it's something different. Only that this take account the action. So you can see they take account the state and action pair, and it's the expected return starting from S and taking the action A.
Okay. So we only have the action.
Yeah. See, yeah. In one only take account the state, and then another one take the account the state and the action that they can take, and then the reward that we expect to have following the policy in that initial condition. So something um, fundamental for this is the value function have a property that satisfies between them by self. It's a recursive relations. For example, for the state value function, follow this, but no, this is a
This is the same. We saw
yeah, this is
this is the
the
state.
discontinuing
Well,
core returns. But something interesting is that we can see the the actual state value function in terms of the returns the the returns in one step, and the state value function for the next
Step,
step.
the next step.
Yeah, this is this is something tricky to understand here, but later we're going to look better. So
So we have defined the value function for actions and for states. Um, where we what we want to do is to try to maximize or to make that maximum.
yeah,
So what we have is
yeah. You remember that the problem is to find a optimal policy that
yes,
can maximize the total reward. So all these value functions tell us how good or how good bad is a specific policy, and that is good because the value function define a partial ordering over the policies. So we can tell that a policy is better or equal than another one is only
if the
if the
value function is
all the values for all the states for the value function based on the pi policy is greater or equal than our value function based on pi prime. So there's always at least one policy that is better than or equal to all other policies, and that we are going to define or name optimal policy.
and that is going to be the maximum,
The better,
the best for the for
yeah,
that.
or maybe it can be a lot of policies that are optimal, only
Okay,
one,
it's not unique.
yeah. So they share the same the optimal state value function. So the optimal policy have associated value function, a state value function that is optimal for all the possible um, value function for all the states for all the policies, and also for the action value function. He have the optimal policy have associated optimal action value function. So do you remember that we have defined that
The Bellman questions.
the value function has something recursive?
Yes.
So this is one of the biggest equations that can that reinforcement learning used to solve this problem of the
Okay.
MDP. So we have the Bellman equation for the value function. Uh, is in the optimal value function in the state S is equal for the maximum for all the actions possibles over the sum of the all the possible states, and is average of this measure, and also this following the action value function. So um, something that we need to find is to a way or an algorithm that allows to find this optimal policy, but we have the partial ordering, that so only we need to maximize or the state value function or the action value function to find the best, and this defines us a optimal policy.